Okay, good afternoon, everyone, and welcome to our subject, AS 102A, for structural design of steel and timber structures. So for today, we will be discussing the characteristics and classification of timber muna, no? So we will just be focusing ourselves with timber first before we proceed with structural steel. So when we say timber, what we are talking about talaga ba pag we say timber? So before that, here's our outline for today's lecture. So we will be discussing some introduction, okay, and then structure of timber. What is the composition of timber? We have also the different defects that timber experiences while growing up or kapag inaano na siya, prepare for structural use. What are the types of timber? What are the physical properties of timber, and also what are the structural grading methods being used to classify timber into groups. Okay, so our learning outcomes for this evening are as follows. So first is to discuss yung timber in construction. Next is to examine the important structural components of timber. To enumerate also the defects of timber of that timber experiences. So we have actually four types of defects that it experiences. To discuss also the classification of timber based on visual and machine grading approaches. So ito yung ilan sa structural grading na ginagamit commonly, no, sa practice to classify or to group our timber into a specific group or um, species depending dun sa characteristic niya. Okay? So, but before that, we need to discuss first kung ano ba talaga sa timber. So, as per definition, timber has always been one of the more plentiful natural resources available and consequently one of the oldest known material used in construction. So, before na-discover yung usage ng concrete and also the usage of structural steel in our structures, ang pinakauna talagang ginamit ng ating ancestors are si timber or structural wood. Okay? So, especially dito sa atin, a tropical country, very present yung mga pwedeng uh, pwedeng gawin na structural member na mga wood, no? Tapos paglipas ng panahon, sa kagagamit natin ng mga puno, no? Medyo naubos siya, no? Medyo during our era now, or on the 21st century, medyo naging scarce na yung material na yan. That is why timber structure or timber design is not very familiar, not very common na nowadays because of scarcity. Na if you opt to use this kind of material, it will cost you something or it will cost you more rather than using yung mga ano na no bawa concrete, no, kasi when we try to use structural wood nowadays, it would require ano ba, transportation, depende kung saan siya i-harvest. And then, you need to have permit from different organizations now. Kasi we are trying to preserve yung mga remaining species natin kasi most of the species na can be used for structural are very limited na. Kaya nga the researchers nowadays are trying to look for alternative materials that can be used in construction. Okay? Versa timber is a material that is used, sabi nga natin, for a variety of structural forms. Okay? So we can use it as beams, columns, truss, girder, and also sa mga building systems such as piles, deck members, railway foundation, and for temporary forms in concrete. No? So ngayon, ang pinaka-prevalent na lang na nakikita natin sa mga simple na construction, syempre si coco lumber na lang, no? Na ginagamit natin for, pag hindi scaffolding, is sa formworks, no? Pero beside doon, hindi na masyado nagko-construct ng mga structural frame o structural system na ang main resisting frame natin is made up of wood. Okay? So, minsan yung mga rest houses na lang yung mga pinapadesign sa atin na gano'n na usually dahil nasa nature, malapit yung mga ganong areas, minsan para for, sabi nga nila, aesthetic purposes, mas maganda yung wood pag gagamitin natin sa mga structure na yun. Pero before, like for example, sa mga pier, no? Makikita natin, gamit pa yung mga wooden, mga timber natin as piles na sinasubmerge pa natin talaga sa dagat, which can withstand yung ano, no, yung forces na pwedeng ibigay nung ano, nung wave, tsaka kapag may mga typhoons, no, yung mga strong wind forces natin. Okay? So ilan na to sa mga example ng mga timber structures. And then timber structures can be highly durable when properly treated and built. So examples of this are seen in many historic buildings are all around the world. Okay? So it possesses excellent insulating properties, good fire resistance, lightweight, and aesthetic appeal. No? So ito yung sinasabi ko kanina dahil nga kung very well treated yung mismong material natin, yung timber, yung structural wood natin, halimbawa, hindi siya madaling amagin, hindi siya, meron tayong ina-apply para maging siyang more fire resistant, mayroon tayong mga pinapahid sa kanya, no? Before we cast yung mismong timber, meron tayong mga ina-apply na mga ano ba, epoxy ba tawag doon, no? Basta kung ano man yung pwede natin treatment for timbers. Okay? So, to help strengthen yung properties niya, kaya nagagamit si timber talaga for structural purposes. And a great deal of research carried out before pa, no, has provided us with comprehensive information sa mga structural properties ng timber. Kasi nga, dahil sa technology na din, yung mga iba't ibang species, dahil magkakaiba nga sila ng characteristic, na develop na ng mga standard, mga code, no, mga standard codes, yung mga mechanical properties na kailangan natin para kailangan pag nagde-design tayo ng mga structural members natin, pwede natin i-assume yung mga allowable values na identify nila through experiment. Okay? Then, now we punta tayo doon sa structure ng timber. Okay? So, mature trees of whatever type are the source of structural timber. Pero syempre, hindi naman lahat ng puno pwedeng gagawing timber, structural wood, no? Bakit naman yung mga ibang wood, no? Kasi depende siya talaga dun sa strength capacity niya, and meron lang group of or species na ina-allow for structural purposes. Some species are good for as cladding, no? Pwedeng gamitin lang siya for cladding, for architectural purposes. Pero minsan hindi siya pwede for structural kasi they cannot carry weights, no? Kaya later may papresent tayo na group of timbers depending do sa strength requirement natin. Okay? And it is important na tayo as designers should have knowledge dun sa nature and growth patterns nung puno natin na ino-consider in order to understand yung behavior niya under variety of circumstances. So basically, meron 3 subsystems na kino-consider kapag pinag-uusapan natin ang isang puno para pag-aralan yung kanyang growth patterns. Ang mga subsystems na to are the roots, the trunk, and the crown. Okay? So, starting off with the roots. So, si roots are there by spreading through soil as well as acting as foundation. So, it enabled the growing tree to withstand wind forces, and then they absorb moisture from the minerals from the soil and transfer it via the trunk to the crown. So, mainly, si roots are the one responsible for keeping our trees at its place, no? Especially when typhoon strike dito sa country natin, no? Sila talaga yung main element o main part o subsystem ng tree natin at tumutulong kung gaano siya titibay dun sa kung gaano siya katibay dun sa wind forces natin. And also, they are the one looking for food para dun sa vitamin o dun sa nutrients na kailangan ng tree natin. So once na-absorb nila yung nutrients na kailangan nila, they are the one who transfer it to the trunk, then the trunk will transfer it to the crown. Okay? So depende kung ano man ang binibear niya as a tree. Okay? So yan yung una sa ating subsystem. Next, we have the next one, which is yung trunk natin, which is the most this is the most important part for us designers, no? Kasi si trunk, ito yung ginagamit natin for structural purposes. Ito yung ginagawa natin as structural material. Okay? So the trunks provide rigidity, mechanical strength, and height to maintain the crown. Okay? Also, they are the one who transports moisture and minerals papunta nga doon sa crown, and yung pag-transfer ng mga dagta, no, from the crown. Okay? So, ito yung cross-section ng ating trunk, which is kailangan nating maintindihan kung ano yung importance ng mga parts na yan. Okay? So, these photos are identical lang naman siya. Different lang siya ng ano, no, ng views, and siguro yung pagkakapangalan lang sa kanya, no. Pero wood in general is composed of long thin tubular cells, no. So makita natin may parang tube dito na nagdi-differ lang siya ng diameter, and as we go beyond dun sa, or habang lumalaki siya mula dun sa pit na tinatawag natin yung pinaka gitna ng ating timber, yung ating wood, yung ating trees, no? May mga different na tawag na siya. Okay? So the cell walls are made up of cellulose, and the cells are bound together by a substance known as lignin. Okay? So yun yung bonding agent natin, or yung bonding, nagbaband dun sa walls natin in between ng mga cells na nandyan. Okay? So most cells are oriented in the direction of the trunk axis. So most cells are longitudinal in nature. Okay? So except for cells known as rays, which run radially across the trunk. So makikita natin dito, may mga parang may mga pailan-ilan na arrows, no, na lines, no. Tatawag natin medullary rays. Okay? So in temperate countries, a tree produces a new layer of wood just under the bark in the early part of every growing season. So every growing season, nagkakameron ng growth, no? So this growth is at the end of growing season or during winter months. So wala man tayong winter, no? So natatapos yung ano natin, edi after ng summer, no? So this process results in clearly visible concentric rings. Ito yung mga nakikita natin mga rings, which are known as annular rings or growth rings na tinatawag natin. Okay? So, yan yung mga yon na minsan itong mga rings na to, okay, are considered or we can consider it as the age nung timber natin. So, kung ilan yung annular rings niya, yun yung edad nung ating wood in years, no? So, every year nagkakameron siya ng one ring, padagdag ng padagdag yun every year. So, sabihin nag-create siya ng another layer as the years goes by. Kaya makikita nyo from a stem, no, yung from nag-sprout siya from seedling, naging stem. Tapos eventually as the years goes by, nagiging siyang tree, no? Papansin natin paano siya lumaki ng gano'n. So, ganun yung nangyayari sa kanya. So, kino-cover niya. So, yung may, yun nga, sabi nga kanina, yung may new layer of wood dun sa bark ang nag-grow every season or every year, no? And this produces annular rings. Okay? So, yung annular band of cross-section na malapit dun sa bark, yung malapit dun sa mismo exterior natin, ang tawag natin doon ay sapwood. Okay? And then yung malapit sa pit o yung mas darker na areas ng ng annular band, natawag naman natin heartwood. Okay? So the central core of the wood which is inside the sapwood is heartwood. Yun nga yung mas darker. So to give mechanical support to the stiffness of the trunk. So yun yung function ni heartwood. Ang function naman ni sapwood, since sap nga yung tawag sa kanya, no? Sapwood is siya yung medium of transportation nung sap natin from the roots papunta dun sa leaves natin. Okay? And then, ano pa ba dyan ang halaga? So, yung ano lang siguro, yung sa layer natin, meron tayong dead bark, which is the most exterior part. And then, every layer nun, meron tayong live bark. So, ibig sabihin, ito yung hindi exposed sa air na portion ng atin. And then, yung inside pa ng live bark, before tayo mag-sapwood, we have the cambium. Okay, or yung cambium cell layer. So, makikita din naman ito dito sa cut dito sa portion na to. Okay? So, yan yung sa dun sa cross-section ng trunk natin. Okay? Then, last of our subsystem is tinatawag nating crown. Okay? So, crown provides as large as possible a catchment area covered by the leaves. So, this produce chemical reaction that form sugar and cellulose which cause the growth of the tree. Okay? So, yung crown it serves as the collector, no? Na nagproduce ng sugar for the tree to grow, no? Without growth, hindi magde-develop yung strength ng ating mismong timber. So kung walang strength, we cannot use it for structural purposes. Okay? Kaya this subsystem has their different roles to do for us to harvest yung required na material natin na magagamit natin for our buildings. Okay? Next, we go do sa timber orientations. Okay? So, in timbers, we will consider three orientations when we are talking about dun sa fiber natin o dun sa axis natin, no? So wood fibers are formed in the living tree with their long dimension approximately parallel to the axis of the trunk. Kaya makikita ninyo, naturally ang fiber direction natin is always longitudinal or kung nasaan yung length ng ating ng trunk natin, no? So dito yung fiber direction natin. Wood is classified as anistrophic. What does it mean? It means na distinct and different yung mechanical properties niya dun sa different axis niya, no? So when we are talking about the axis, halimbawa, kinuha mo yung capacity niya dun sa longitudinal, it would be different value if we look at the tangential area. Okay? Kapag radial area yung pinuha natin. So, kaya naging anisotropic yung wood natin. So, hindi mo pwedeng pag-comparein, ibig sabihin, yung strength in the longitudinal direction versus the tangential direction. Okay? And here's our three major axes, no? So, we have the longitudinal axis. So, that is the parallel to the fiber direction. So, take note of the definition, no? Kasi later, yung mga nakalagay na parallel and perpendicular, yan yung kailangan nating tandaan when we are pertaining dun sa mechanical property na tinitingnan natin sa table. Okay? So pag sabing parallel to the fiber, ibig sabihin longitudinal axis yun. So along lang tayo dun sa trunk, no? So ito yung fiber direction natin. Longitudinal is just the same direction. Okay? Then we have tangential and radial. So both of them are perpendicular dun sa fiber natin. So kung ito yung fiber natin, yung isa is perpendicular along the horizontal axis, and then yung isa perpendicular siya along the vertical axis. So yung tangential axis is the one perpendicular to the fiber, tsaka tangent siya sa growth rings natin. So papansin niyo ito yung cross section ng wood natin. Ito. Wala pala akong pointer dito pa, sorry. Ito yung cross-section ng wood natin. Okay? And then, pag kinuha natin yung strip o yung plank na to, no? So, we can see yung mga annular rings natin. Ito yun. Okay? So, pag nag-tangent tayo dun sa growth rings natin, so, yan, naka-tangent siya, no? So, ibig sabihin, ano lang siya sa isang point, no? nag-coincide lang siya sa isang point, tapos going dito sa direction to, tangential axis yung pinoconsider natin. Then when we are talking about normal o naka-perpendicular dun sa annular ring natin, no? So parang halimbawa, parang nakapatong, no? Dito sa annular ring natin. So radial naman siya po dun sa ating growth rings. So these three axes will be very significant later on when we are designing, especially when we are considering the bending strength and shear strength nung ano natin, ng timber natin, kasi timber has different value for parallel to the fiber and perpendicular to the fiber strength. Okay? Next, we have yung different defects in timber. So owing to the fact that that wood is a material which is naturally occurring, there are many defects which are introduced during growing period and during the conversion and seasoning period. So during nung growth pa lang nung mismong timber natin, kasi si timber hina-harvest siya decades before we can use it as a structural member, no? Kaya you can imagine na if it's present in an environment na exposed sa different phenomena, ano, naturally magkakameron siya ng defect based sa iba't ibang classification, no? Pwedeng while growing, ma-experience niya dahil sa surrounding niya, no? And also, kapag halimbawa ina-harvest na siya. So when we are trying to harvest yung mismong structural timber natin or trying um, to cut yung mismong material natin into our desired cross sections, minsan nagkakameron din siya ng defect. And these defects are classified as follow. So we have yung mga natural defects, chemical defects, conversion defects, and seasoning defects. Okay? So let us try to discuss muna yung natural defects natin. So natural defects occur during the growing period. So this includes the following. So number one is yung cracks and fissures natin. So minsan, di ba, pag nakitinigin na natin yung mga wood, mapapansin mo parang uh, may mga unwanted um, na embedment dun sa mismong bark niya, no? So that is caused by yung crack and fissures niya, na minsan nagiging cause siya o beginnings ng decay. Okay? So nung pagkalanta nung portion na yun, no? Yung pagkamatay ng portion ng may mga cracks niyan. Then we have the nuts. So ito yung common feature ng structural wood. So itong nuts, ito yung parang pag meron kang plank, ito yung parang peklat, no? So may itsura dito. Yan, ito yung nut. Okay? Yung parang peklat sa wood, makikita natin. Pag halimbawa nag-check kayo ng um, mga nakat na wood, no? May mga ganun na parang peklat. So that those are actually branches na na parang hindi natuloy mag-sprout. So normally originated at the center of the trunk or branch. Okay? Then we have yung mga grain defects natin. So di ba kanina sabi natin yung fiber grain natin is longitudinal yung direction niya. Pero minsan, grain defects will occur in the form of twisted grain, cross grain, or flat grain. So minsan nagiging diagonal yung grain natin. Okay? May cross grain and we have flat grain. Okay? Next, we have yung mga fungal decay. So this may occur in growing mature timber or even in recently converted timber. So ito yung isa sa problema. No? Once you see timber we have that has fungal infection or infected by fungi, kailangan i-reject mo yung timber kasi it will be a problem later on once na na-install mo siya and then you disregarded na meron siyang fungal decay. Eventually, yung structure mo will be baka maubos siya ng mga fungi, no? Or ang ano pa is yung strength niya mismo, maapektuhan yung strength niya. Okay? Next, we have annular ring width. So this can be critical in respect to the strength in that excess. Width of such rings can reduce the density of the timber. So kapag very wide yung width ng rings natin, it means na yung density natin is lesser. And when density is lesser, definitely yung strength ng mismong timber natin is lesser. Okay? So after natural defects, we have the chemical defects. So ito na yung kapag nag-ano tayo ng treatment, no? So this may occur in particular instances when timber is used in unsuitable positions or in association with other materials. Okay? So minsan, pag kailangan natin siyang gawing anong tawag doon? Uh, Modular with other materials, no? So, minsan nagkakameron ng defect, no, kapag may exposure siya to other chemicals or materials, okay? So, timbers such as oak and western red cedar contain tannic acid and other chemicals na nakakapag-corrode daw ng metals. Okay? So, yeah, so siguro yung dagta niya, no, once exposed dun sa metals, especially kapag composite yung mismong structure natin, medyo ano yan, mahirap yan kapag ganun yung ano natin. Then gums and resin can inhibit the working properties of timber and interfere with the ability to take adhesives. Okay? So, ibig sabihin minsan pag pag di ba kapag tinitreatment na natin, pag finishing na tayo, minsan nalagyan natin ng resin si timber. So, minsan nagre-reduce daw yung strength yung capacity ni timber, yung kanyang property, no? Which are caused by chemical defects. Next, we have conversion defects. So, for a while nga lang, it's getting dark. Okay, yeah. So conversion defects, these are due basically to unsound practice in the use of milling techniques or to undue economy in attempting to use every possible piece of timber converted from a trunk. Okay? So minsan, sa kagustuhan natin di ba, circular or round or tubular yung shape ng ating timber and we want to maximize the use of everything or every area or every piece ng mismong timber natin, we try to cut or to use machine, no, to cut yung mismong trunk natin. And sometimes hindi talaga siya nagiging perfect na, halimbawa rectangular yung shape. And one good example ng defect na to is yung tinatawag nating wane, no? So yung wane katulad nito, nasa na ba yun? Yan ito. Nagkakameron siya ng mga bangas na sa tabi-tabi. Yan, so yung ganito, no? So parang nagiging hexagonal yung shape niya. Kasi minsan, yung edge na pinagkunan natin ng portion na to are actually doon na sa circumferential ng bark, no? Nandun na sa, kung masatarang tayo, maganda yung mga shape ng mga nasa bandang gitna. Pero yung around do sa perimeter, hindi natin ma-perfect yung shape niya, no? Then we try to use machine to smoothen yung sides na yon na yun yung nagiging cause ng defect dun sa structural element natin na timber. Okay? Then we have yung seasoning defects. So directly related dun sa movement that occur in timber due to change in moisture content. Okay? So halimbawa exposed sa water yung ating halimbawa furniture yung pinagamitan natin ng timber, halimbawa tukador, no? Halimbawa then unfortunately, halimbawa sa area nyo is nagpa-flood pala, no? May halimbawa na-submerge yung half nung portion ng furniture na yon. After nung ma-submerge sa water, after some time, mag-expand yung mismong wood natin kasi nga nag-increase yung moisture content niya. After nun, makikita ninyo, hindi nyo mabuksan yung drawer kasi nga nag-expand na yung mga parts natin. So, hindi na siya pag pinersa natin, hindi na siya babalik sa natural state niya. So, kasi si wood or si timber is very prone talaga to shrinkage saka expansion, especially sa mga extremely hot and extremely cold weathers, no? Kaya mapapansin niyo yung mayroon mga cases na bawa sa door na lang, no? Minsan kapag wooden door, hindi siya nagsasara kasi nag-expand siya sa sobrang init, hindi masara yung door. Minsan naman, may awang siya kasi nag-shrink siya due to very, very cold temperature. So, yun yung sa ilan sa defect ng seasoning defect in timber. So all such defects have an effect on structural strength, no? So laging ganon. Lahat ng defect na pinag-usapan natin, it always affect the strength and capability ng timber natin to withstand forces in the future. Okay? Then next we go dun sa types of timber. So trees and commercial timbers are divided into two groups. Tinatawag natin siyang softwoods and hardwoods. Okay? Pero this terminology doesn't refer dun sa softness or hardness ng wood natin. Ang ibig lang sabihin, pag softwood, sila yung generally evergreen with needle-like leaves comprising single cells called trachide. No? So, ano ba yung characteristic ng softwoods? So, yung softwood daw, meron siyang quick growth rate. No? It can be felled after 30 years. So, 3 decades lang, pwede mo na siyang i-harvest. Imagine 3 decades bago mo ma-harvest. No? Resulting in low density timber with a relatively low strength. So, since medyo mas bata yung kanyang maturity o yung edad ng wood natin, mas lesser syempre yung strength niya. Pero yung strength niya, although low, is capable of withstanding na siguro mga pwede itong gamitin sa mga furnitures, no? Hindi yung mga extreme applications. Okay? So, for light applications only. Then, it is generally poor, has poor durability qualities unless iti-treat natin siya with preservatives. Okay? Dahil din dun sa bilis ng kanyang pag-mature, they are readily available and comparatively cheap sa market. Okay? So, ito yung downfall naman ng timber, no? Itong sa softwood, after 30 years pa siya bago ma-harvest. Kaya ang isa sa rising na na alternative sa timber is yung natin, yung bamboos, no? Kasi in comparison with timber, si bamboo can be harvested 3 to 5 years lang, no? 3 to 5 years lang na-attain na niya yung strength niya, then mas mabilis pa siyang dumami. Unlike kay timber, kay wood, it would take decades before you can harvest or at least use structural grade wood, no? Kaya papansin niyo kung massive talaga yung structure and you need massive quantities of wood, it would cost you much or very expensive kasi it would come from different resources from different parts of the world, no? Kasi hindi naman sa isang area lang tumutubo yung ganyan, no? Hindi naman pwede natin putulin lahat sa isang area lang, no? Kaya gano'n. Then we go do sa hardwoods natin. So si hardwoods are generally broad-leaved trees that lose their leaves at the end of each growing season. So meron siyang cell structure na yung thick-walled cells niya are called fibers and yung thin-walled cells niya are called vessels. Okay? So, ano pa bang meron dito? Yung characteristic naman niya, so it grows at a slower rate than softwood. So, yung kanyang time to mature is 100 years, no? So, imagine a century bago siya mag-mature. Yung talagang mature, no? So, since it would take a century to mature, syempre yung kanyang density and strength are much stronger. So there is less dependency on preservative for durability qualities kasi through time, dahil sa tagal ng panahon, mas na-develop yung strength niya. And then due to the time taken to mature, syempre nga yung transportation cost is more expensive compared din sa mga softwood, no? Kumbaga, makakapag-harvest kang 3 beses na softwood versus sa 1 harvesting period ng hardwood. Okay? Then we have also the physical properties of timber. So due to the fact that timber is such a variable material, its strength is dependent on many factors which can affect independently or in conjunction with others, adversely affecting the strength of the workability of the timber. So, madaming mga properties na pwedeng consider. Pero among of the most important properties are as follows. Yung moisture content, yung density, yung slope of grade, tsaka yung timber defects. So, when we say moisture content, ito yung dependence sa resistance yung capacity ng timber natin to resist decay, no? Kasi yung strength ng timber is dependent sa moisture content. And most timber has a moisture content of 17% to 23%. Pero beyond that or below that range, pag na-remove natin yung moisture, shrinkage will occur, no? Which will degrade also yung strength capability ng timber natin. Okay? So kapag halimbawa inaano natin pag hinarvest natin si timber, ang pinakamagandang preservation sa kanya is ini-air dry dapat siya. Okay? Meron kasing yung nilalagay sa oven para mag-dry, no? The problem with oven drying is masyadong nare-reduce yung moisture content and nagiging marupok yung timber, which cannot be the case when we are trying to contain or to use yung structural strength niya. Then we have yung density. So this is a measure of the timber's solid substance. So ratio ng oven dry weight to the weight of volume of water. Okay? So si density, mas higher si density, mas higher si strength. So parang directly proportional silang dalawa. Then we have the slope of grain. So sabi natin, di ba kanina, si grain is always longitudinal in direction. So in many instances, yung angle ni grain in cut section is not parallel dun sa longitudinal axis natin. And this causes significant drop in bending resistance. Okay? Kasi kung halimbawa nag-iba yung direction niya, syempre yung capacity na yung transfer ng force will be different also. So if the angle of deviation increases o malaki yung slope natin mula dun sa longitudinal axis natin, yung strength natin will definitely decreases. Kasi pag naka-incline na siya, yung resistance niya is madidivide na siya sa dalawang direction, ano, pag naka-incline siya. Unlike kapag halimbawa naka-parallel lang siya sa longitudinal direction, it will focus only on that direction and will help dun sa strength ng mismong timber natin. Okay? And then as discussed earlier, yung timber defects na all of the defects mentioned earlier are all causing our timber to decrease in strength, no? Habang na-experience yung mga defects na yan. Okay? So, iyan yung mga ilan sa important properties, physical properties sa timber. Next, we have yung structural grading of timber. So, structural grading is a process by which timber is sorted into groups. So, ito na yung pwede natin siyang i-classify, no? So, in classifying or structural grading, it can be performed in two ways. So, meron tayong visual stress grading and machine stress grading. Pero in theory, kahit anong method yung gamitin natin, pwede natin i-apply dun sa timber natin. However, to be valid or to be consistent, ginawa is ni-standardize to ng ating code, no? Para pare-parehas tayo ng hatol dun sa material na yon. Kasi kung hindi siya i-standardize, it would be may bias yung pag-ano sa kanya, pag-grading sa kanya kapag wala tayong standard na susundin. Okay? So what do I mean? Like for example, kapag visual stress grading yung pinag-uusapan natin. So by the word itself, visual grading, so yung process niya is by observation. So may examiner na nag-examine ng each and every piece ng timber natin, and then they would classify kung saang group siya belong. So may checklist lang siyang o may standard lang siyang chine-check. Halimbawa, yung mga nut, kung may location ng nut, may size ng nut na ganito, dun niya binibase yung strength niya. Okay? So depende sa number of defects present, tsaka sa size niya, dun niya i-classify kung which group siya belong, no? So medyo bias yun kasi ang downfall nun, if ever yung examiner is not well trained or not well experienced sa pag-identify ng mga timber natin, the result will be biased, no? So baka mamaya in-assume niya na malakas yung strength nitong nung timber na to, ayun pala, dapat nasa low strength range lang siya. Okay? So it would, ang magsasuffer doon will be the project that will be supplied with that timber, no? Kasi substandard na yung magagamit niya. Okay? Then we have yung machine stress grading. So using machine to bend each piece of timber. So minimeasure yung stiffness ng kada piece, no? And then ina-identify kung anong stress grade siya. So pinapatakbo siya sa machine and then ayan, i-identify ni machine kung ano yung capacity niya. So pwede din to kaso it would cost ano na medyo expensive siya, no? In comparison with visual stress grading. Okay? And then in the Philippines, meron na tayong grouping ng mga yan. Okay? So, according to the National Structural Code of the Philippines, the Philippine wood species are grouped into 4. We have yung high strength group, moderately high strength, medium strength, and moderately low strength. So yung mga strength na sinasabi na yan, makikita nyo na lang yan pag chinek nyo yung mga capacity niya dun sa table later on. Okay? So makita nyo sa high strength group, ayan, ito yung mga wood. So makikita nyo dito sa mga nakalista, ito na yung ibig sabihin yung mga species na pwedeng gamitin for structural purposes dito sa Pilipinas, no? So makita nyo wala si ipil-ipil dito, no? So hindi na siya sinama kasi hindi siya structural wood. Okay? So, sa high strength, ang usually ginagamit is yakal, no? So, depende din sa designer kung anong gusto niya or sa availability in the market, kung anong meron. For moderately high strength group, ang minsan lang ginagamit, guijo, no? Kamagong, yan. Then mahogany, and then nara, of course. Okay? For medium strength group, apitong is the one na medyo kilala, no? And lawan. And then, not sure dun sa iba, no? Pero apitong, lagi kong na-experience si apitong. Okay? Then for moderately low strength, ayan, wala akong nagamit pa dyan. Pero definitely, these are the structural wood species na available dito sa country natin. Okay? And then we have also yung mga stress grade ng Philippine woods. Okay? So, si National Structural Code of the Philippines, ginroup niya into 3 yung mga stress grade natin. Okay? Sa 80%, 63%, and 50% stress grade. Okay? So, depende doon sa mga, sa inclusion niya. So, siyempre, paglaki ng stress grade, pagmahal ng presyo, paglaki ng, niya, capacity niya, no? So, halimbawa, so 50% graded lang siya. Okay, so depende sa sa klase, ba high strength group yung pinili mo, tapos yakal, meron siyang bending and tension parallel to grain. So ayan, yung sasabi ko kanina. Yung parallel to grain, ibig sabihin niya along longitudinal axis, ito yung kanyang capacity ng bending and tension. So same siya ng value, no? Halimbawa, yung modulus of elasticity niya in bending, ito yung value. Compression parallel to grain, and then perpendicular to grain. Okay? So, ayan. And then shear parallel to grain. Okay? So, ito yung mga capacity i-refer natin once na nagde-design na tayo. Kaya pag halimbawa, nagde-design na tayo, when sa given, ang binigay lang is yung pangalan ng species, no? Halimbawa, ang nilagay ay malabayabas yung ginamit na timber. So, dapat alam nyo na agad na i-check nyo kung anong stress grade percentage yung requirement, and then ito yung gagamitin yung mga allowable na values. So, kung halimbawa, dapat ready yung table natin to support us with the capacities available dun sa mga species na yan. Okay? So, hindi naman siyempre papamemorize yan, no? So, that is always provided to you. Okay? So, ayan. So, yan po yung ating structural wood. So, that ends our lecture for today. So, yan lang po. So, I hope nakatulong for you to have at least a background of what we will be dealing with, no? Kung ano yung material na gagamitin natin. Question before we end our lecture. Okay.